Welcome back. In this episode, we're actually going to start writing Java code. Right now, I'm in a folder called 2048 Java, and inside of it are two directories, bin and source. If I open source, I have a directory called com. If I change into that, I have a directory called addNewNumber. Within that, I have a directory called Java 2048, and within that, I just have one text file. This is actually a note I left myself that isn't important anymore, so I'm going to remove it. I can't delete it because it's busy and I stopped the job rather than actually quitting it. So I'll just leave it there for now, but it's not important. I'm going to start a few new files. The main one will be Java 2048.java. We'll also have to make one called game.java. Now I'm going to open that first class, Java 2048, well actually it's listed last, but the main class, in a text editor. Make it a little bigger. First thing I'm going to do is declare the package that it's in, which is com.addNewNumber.java2048, which is why I have the folders set up the way I do. And then I'll open the class with the declaration public class Java 2048, opening and closing curly braces. And within it, I'm going to have a public static main method that takes a string array args. And at the moment, I'm not going to do anything. Let's save the file. So we'll leave that class for now. We'll have to open up game.java. It belongs in the same package. Package com.addNewNumber.java2048. And this is a class called game, matching the name of the file. And this is going to be that third class we talked about that's going to store the actual data for the game. One of the main things it has to store is a private integer array, a two-dimensional array. We'll call it the game board. And we're going to make a constructor for the class that will initialize the array as a 4x4. Now for testing purposes, I'm going to create a method for this class that will print out the array. So I'll call it public void print array. Now if I understand Java correctly, we won't need to initialize the array by explicitly telling it to fill it with zeros. They should all start at 0, but we'll have to test that. We'll do for integer array x in game board. This will be a for loop. And within that for loop, we'll do for int y in x, and we'll print out that line of the array, that row I should say. The way we'll do this, we'll do %6d, 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 that's 3, we'll need to do that 4 times. to put that in a string though. No, this is actually the wrong way to do this. We don't need this inner for loop. We'll just have to do it like this. X0 to get the first one. X1, X2, X3. And this should, actually I can't do print line, I gotta do format. This should print out the row in columns 6 characters wide. Now we'll save this file and open the main class. And it's in the same folder, so we shouldn't need to import anything. We'll create game G equals new game, which should create an instance of this game class over here. It should immediately call the constructor and initialize the game board as a 4x4 array of integers. And I'll do g.printArray. Hopefully this works. I'm a little bit fuzzy on this part. I want to compile this. So I'm going to go back to the source folder. And I'll say javac. I'm going to tell it to put it in the bin directory. And I want it to compile com/AdamPJr /Java2048/star.java. We'll see how this goes. There is an error. Okay, I messed up the main method, so we'll make this void. The error I had was that the main method has to match a certain signature. It has to be public and static, and also has to have a return type. And I don't need to return anything, so I'm going to use the return type void. That was the only error it showed me, so I'm going to try it again. Now let's see if that worked. I'll go back up, change into bin, and it looks like it created all of the files for the package automatically, which is what it should do. Change into com, change into AdamPJr, change into Java2048, and it has both of them. Since I usually only make programs with 1 or 2 classes, I usually compile and put the class files in the same directory as the Java files, so I'm not usually playing around with all the complicated directories that I'm playing with now. I think what I need to do is go back up to the bin folder and specify the package javacom.AdamPJr.java2048. Okay, I'm actually making a lot of egregious errors right now. I obviously can't use main with a capital M. I have to use main with a lowercase m. This particular method right here is what Java looks for to run first, and it has to be exact. And I had it off by 1 character. I had this capital M here, and I need the lowercase m. I'm playing with too many different languages and I'm getting confused. In C#, I believe it's capital M, and that's what I usually mess with. So that's why I'm getting this wrong. But no excuses. I'm still in the right place. I'm going to try the same thing. Oops, I got to recompile the whole thing actually. So change back to source, and I'm going to look up through my past entries and find when I compiled. What is going on here? Oh, I didn't effectively change the directory. Now that should be compiled, so we'll change back to the bin folder, and now try javacom.AdamPJr.java2048 pushRight.java2048, and hopefully it finds the main method this time. It did. And it prints that array of zeros. It didn't do it exactly how I wanted, so I'm going to edit that method. I'm going to add a %n to the end of this formatted string, which is going to add the new line, so that instead of putting them all together, it's going to put the 4 from the current row and then put a new line character so that the next time it goes to print the next row, it'll be on a new line. So if I save this, I can change back to source, do my compiling again, change back to bin, and run it. Now it prints how I wanted it to. So without me having to initialize the array to all zeros, it did that automatically because the default value for an integer is 0. So now what we have to do is create a method to randomly populate either a 1 or a 2 into this array and make the methods to respond to going up, down, left, or right, and make sure it combines numbers when it needs to combine them. So back to our text editor. This might be a little bit complicated and it might not be the best way to do it, but this is what I have in mind for now. I want to create a public void method called addNewNumbers. And what's going to need to do first is consider the array it has and find all the places that are 0, which will represent an empty space. Because we can't just randomly pick one, because as the game goes on, the significant majority of these spaces might be filled with something. They will be filled with something. So we need to look for all the zeros and then randomly choose from those positions a place to add the new number. Also, there has to be a 90% chance that it's a 1 and a 10% chance that it's a 2. So the first thing we'll need to do is make a new array list of integers, as I like to use array lists. They might not be the fastest thing in the world, but I'm not at the level yet where I know how to do things the fastest way possible. Hopefully this is fast. An array list of integers, we'll call it empty spaces. And we'll go ahead and initialize it as a new array list of integers. An array list is different from an array in that it can vary in size. Now that we've done that, we'll have to do an old style for loop. Instead of this fancy one we did here, where we just iterated through all of them, we're going to need to do it the old way because we'll need access to a specific number, or the specific position rather, that we're in within the array. So we'll initialize an integer x to 0. We'll continue the for loop as long as x is less than 4. And at the end of each cycle, we'll increment x. And within that, we'll do the same thing, but with y. Y, as long as y is less than 4, and increment y. And then we'll do if gameboard x, y is 0, then we'll add those coordinates to empty spaces. Empty spaces dot add before this we'll create the variable an integer array called C for coordinates that will have the coordinates for the space. Let me double check something I have over here and make sure I'm doing that right. I think I am. So then I can add that array of the two coordinates to empty spaces. I don't need to worry about if it doesn't find any, because before this method will be called in the final product, we'll have already checked to see if the game is over. So outside of the outer for loop, we'll continue on, and empty spaces will now be populated with a list of coordinates that have a 0 in it. So now I have to choose one randomly. And the best way to do this might be to give the game class its own object called random over here, and I'll override my window looking up stats of the World Cup with a search for the Java documentation. And what I'm looking for is the class called random. I'm just going to go ahead and find that. It's in java.util. It looks like their next int method is overloaded so that I can pass an integer into it, and it will return a pseudo-random integer between 0 and the specified value, but it won't include the given value. So if I put in a 4, it will give me a random number between 0 and 0 to 3 inclusive. So that's good to know. We can go back and in order to get access to the random class, we need to import java.util.random, and the game class will have its own randomizer. We'll call it private random r equals new random. Now I need to pull up the array list documentation real quick. I'm constantly searching this documentation because I don't have everything memorized. What I'm trying to do now is find out how to get. This is the one, returns the element at the specified position. I just need to get. Okay. I just want to know how, once I have a random number, to retrieve something out of the array list from the specified index. We'll also need to use size to see how big the array list is once we call this. So the first thing we need to do is create an integer called choice and r.nextInt, and we'll pass in empty spaces.size. Now if I understand the size function correctly, if there are 4 empty spaces, the size should return 4. And then the next int will return a number between 0 and 3, which is fine because index will start at 0, but the size will count all of them starting at 1. So this should work, and if it doesn't, when we run it, we will get a index out of bounds exception, and then I'll change it. I also need to create a number chooser, which will also be a next int at 10, which should return a value from 0 to 9. And if the value is 0, we'll add a 2 to the board. For all the other cases, 90% of the time, we'll add a 1 to the board. So int new number will set to 1, but if number chooser is 0, then we'll change new number to a 2. And then we need to grab the coordinates, which will be empty spaces dot, what was that? Get choice, which is this random number here, which will be a number between 0 and 1 less than the size of the array list, empty spaces. And we'll get whatever pair of coordinates resides at that index and store it in this variable, int array coordinates. Now we'll take empty spaces and we'll get the first number in our coordinates array, which will be the x value, and then the second number of our coordinates as the y value, and we'll set that to new number, which will be a 1 90% of the time and a 2 10% of the time. And that should be all we need to do right now for this function. To test it, we'll make some changes to this. So we'll print the array, which should have all zeros the first time around, and then we'll go through this cycle, let's say 6 times. For int x equals 0, x is less than 7, x plus plus. This will cycle 6 times. We'll call the, I'm going to change the name of this to addNewNumber because we're only adding one new number. G.addNewNumber, and then print the array. So we should see if it's doing this correctly. I guess I should do this 10 times to get a good chance of seeing it put a 2 if it's doing everything right. So let me save both of these. And where am I? I am in bin, so I'm going to change to source, go back. Okay, that's my compiling, and there's a bunch of errors. I need to import something to get array list, so let's bring the documentation back. And this goes in java.util. So I should be able to get away with just changing this java.util.random to java.util.star, or I'll just import the ones I need. java.util.arraylist. Let me save that and see if the compiling works now. Now I have different errors. It doesn't like my declaration of ArrayList int. I've got to find out what I did wrong. Okay, as it turns out, I can't have an array list of a primitive type such as integer, or such as int. I need to change it to integer, which is a object wrapper around the primitive type int. So now let me look down and see what else should change because of that. I don't think I should change anything else. Empty spaces is still a regular array, so all this should be fine. Let me save this. And okay, something is wrong. Yeah, I'm having problems with the difference between the primitive type int and the wrapper class integer. I'll have to do some research and then come back to this. The problem is not that I'm adding integers into an array list. The problem is that I'm trying to add an array of integers to an array list of integers. I need it to be an array list of integer arrays. I think I've solved the problem by changing the array list from an array list of integers to an array list of integer arrays. Let me tentatively save this and see what happens. Okay, it doesn't like that either. There's still incompatible types. It found an integer and it needs an int. So this integer int thing is more complicated than I expected, so I'm going to cheat and create two array lists. One that is for the x values and one for the y values. I really empty spaces y. And on this part, I'm going to take empty spaces x and add a new integer with the x value, and take empty spaces y and add a new integer with the y value. And now I'll have to change some things down here to make sure I get them both. So I'm going to say the int capital X will be from empty spaces x, and then an int capital Y will be from empty spaces y at the same location. If everything was added correctly, they should be correlated properly, so that shouldn't be an issue. And then I'll place a new the new number at position x, capital Y. Let me just look over this real quick. I have empty spaces x, empty spaces y. I add to them here. They should be the same size, so I can choose it based on empty spaces x size. And do I reference empty spaces anywhere else? Oh, this is also a problem. What do I even call that? Game board, I think. Game board. Game board xy equals new number. So there were several problems in there. I think I fixed most of them, hopefully all of them. And do this. That seemed to compile, so let's see what happens when I run it, which now is a while back. Here we go. Okay, a brief scroll through this doesn't show any 2s. I need to change something about the way it prints the array as well, because this is confusing. Print array, after it's printed them all, I'll have to print or format another new line character. This should make it so that they're separated by an empty line, so I can see more clearly what's going on. And if it's random, it should be different this time, so hopefully I'll see at least one instance of a 2. Change directory to source. And compile. Looks like it compiled. Change directory to bin. And run it. And here we go. Start with empty zeros, added a 1 here. Then added the 1 here, kept adding 1s, added a 2 at the top right corner, and it doesn't look like it added any other 2s, so it looks like it's behaving properly. I think it iterated 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1s, and 1, 2, so I guess I was cycling 11 times. Let me see, where is that? I think it should have stopped at 10 times. 0. No, it went 0 through 10, and that's 11. So if I want to do it 10 times, I'd have to change this to a 10. But out of 11 times, it only puts a 2 once, so it looks like everything's working properly. Now we're going to make another method. This will be public void pushUp. This will be the method to update the array in response to the user pressing the up arrow. Let me open up Calculator, or the LibreOffice Calc, I should say, and bring it to an appropriate size that you can see. And let's just fill 1s in some of these. Okay, let's say that this is our board of 1s, so we can visualize this. I'll make it make each of these columns more small. Okay, let's say that this is our 4x4 array. Background, let's make it gray. Let's also give it borders so we can see the cells better. Okay, so this is our array. What's going to need to happen is we're going to have to take it one column at a time, since we're going up, the columns won't affect each other. We'll work from top to bottom, and we'll skip the first one. And we'll have to find every instance of something that's not a 0 and move it up to the highest position that is either empty or equal to the same number. That doesn't involve passing a number of a different kind. So this 1 would move up, and if it moves to a place where there's already a 1, it'll change it to a 2 and empty the new one. Then it will find the next number and move it up 2 spaces and end like this. This one will behave similar. For column B, it will go down, see this 1, move it up to a 2, erase it, then find this one and move it up. For this column, it will skip this 1, find the next one, and move it up 2 spaces, change it to a 2, and erase it. And then for this column, it will just move this 1 all the way up. That's what will happen when the user pushes up. So the first thing we need to do is iterate through the columns, which are the y values. So 4 int y is 0, and there's 4 of them, so y is less than 4, and increment y. This will be the outer loop, and the inner loop will be the x value for the specific row in the column. So for int x equal, and since we're going down, we'll start with 0. 0 will be at the top. We'll do this. Actually, since we'll skip the top one, we'll start with 1 and go through 3. And increment x as well. So the first thing we need to do at each specific location in the board is determine whether or not it's empty. So we'll have if game board xy is not equal to 0, then we'll do a bunch of stuff. If it's not, we'll just continue the for loop. So if this is not true, we'll just go back to the next row in the column. So if it is, we're going to create an integer called value, which is going to be whatever value is at the current position in the game board. Then what we need to do is go back up within the column to find a new place for that value. But we don't want to lose track of where we were, so we'll keep the variables x and y as they are and create a new for loop with a new integer. We'll do capital X and we'll initialize it to the value of x. And we'll keep doing this as long as x. No, we won't use a for loop because we'll need a more complicated conditional statement. We'll make int x equal to x, and then we'll do while x, a few things are true. As long as x is greater than or equal to 0, and game board x y is equal to 0. And for this to work, we don't want to start at x, we want to start it at 1 less than x. So as long as this is true, we'll have x decrement. So that will be going back upwards in the column. Once it gets to a spot where the value is not empty, or it gets to the beginning, we'll stop, and then we'll have to do something with the new information. Either x will be -1 or x will be somewhere else on the array. So if x is equal to -1, then all we need to do is say that game board x plus 1, which would be 0, we can actually just say 0, we'll store the new value, and the old place where we started will be set to 0. Now, we need to do something a little bit differently. Else if game board xy, and we can safely do this part because we already checked right here to see if x is -1. If it's not, then we can safely know that x will be within the bounds of the array. Pulling this back up, let's use this A column as an example. Let's say it's 1, empty, 1, and 1. We're taking this 1 at A3, and we're moving up. That's a 0, so we're moving up again. Now that we see it's something other than 0, we have to make a new decision. So there's two possibilities. Either this number at A1 is a 2, or some number other than 1, or it's a 1. So if the game board is not equal to the value of the specific integer at that location is not equal to the value, then we can place our new value at x plus 1, which would be A2. So if this was a number other than 1, the one that we're trying to move would go to A2. So we go to x plus 1, the same y value, because we're staying within the column, will equal the value. And the game board at the original spot will be set to 0. And now the only other possibility, since we know it's not 0 at this position, and we know that it's not equal to the value, the only remaining possibility is that it's equal to the value. So in that case, we could take the game board x, y, which will refer to A1 in our example right here, and we can multiply it by 2 because we're doubling the value since they're both the same. And then we can take the original location and set that to 0. So these three if statements should include every possible result after scanning for zeros. If it reaches all the way to the beginning, we can safely place the value at the top. If it reaches a number before it gets to the top and it's not equal to the value we're looking at, we can place that value one space below the space we were checking. But if it's the same as the value, we can combine them or double the value there and empty the original space. So let's make sure our braces line up. It will do this process for each row in the column, and then it will do this outer loop. It will do all of this for each column. I'm not sure if this works properly, but well, I was going to say we could go ahead and write the other ones, but before we do that, we better make sure it works properly. So we'll save this and change what's going on here. We'll add a new number 3 times. We don't need to print the array each time. So we'll get sort of a randomized beginning, and then I'll print the array after it's been randomized. And then we'll do this cycle again 3 times, but it'll be slightly different. We'll add a new number. Print the array. And push it up. Also, for the sake of debugging, at the beginning of pushUp, I'm going to add a system.out.println pushing up. So we'll be able to see if it does it correctly. This will alert us to the fact that the next printing of the array should take place after the values have been pushed up. So we'll add a new number, print the array, push the array up, and then print the array again. And we'll do that 3 times. So we'll be able to see a couple different examples. Now I think that should be complete. Yes. So save both of these files. And print my working directory, change to source, compile, hit compiled, that's a good sign, change to bin, and run. Okay, let's test this. We have all zeros, we've added 3 ones initially, and now it has 4 ones, a 1 here, 1 here, 1 here, 1 here, and 1 here. And it pushed up and it correctly put 2's at the top because this one moves all the way to the top and combines with this one, and then these 2 ones move all the way to the top and combine. So far we're doing it correctly. Then it adds a 1 here and correctly pushes that up to this top row, and the next time it adds another 1 and pushes that up to the 2's. So these aren't that many examples, but it looks like it's behaving correctly, so we can go ahead and write pushDown, pushLeft, and pushRight. So I'm going to take this entire function. Let me make sure I've just copy this entire function and change the name of it to pushDown. So for pushing down, we can do the same thing. We can go column by column, starting with 0 and going through 3. We don't need to change this, but we need to move the opposite direction within the column. So we're going to initialize x to 2. Because we can skip the one at the very bottom, which will be x equals 3. We can do this as long as x is greater than -1, and we have to decrement x each time. So everything is going backwards. So all we need to do here is flip everything. So nothing needs to change there. This x will have to be x plus 1 instead of -1. Now I have to think about this fake x. For the capital X, when we were pushing up, we were using the capital X integer variable to move back upwards through the array. In this case, we're going downwards, so we need to do this as long as x is less than or equal to 3. The rest of this can be the same. We're incrementing this one to go the opposite way of the lowercase x. Okay, after we've incremented x as far as it can, downward this time, while there are zeros, we have to check the results of that scan. So if x has gone all the way and reached 4, then we can place the value at index 3 of column y, which will be the very bottom. Otherwise, if we've reached a spot that isn't past the bottom of the array and it's a value other than the value we're looking for, we have to place it at row. We have to place it at row x minus 1, which will be one above the place we spotted. And then the rest of this is the same because all we have to change is all the signs. So hopefully I've changed all the signs. And we could write left and right at the moment, but I'm a little bit scared, so I want to check. So for this 3 times check, we have adding a new number to the array, printing the array, pushing up, and printing the array. I'm going to add to this cycle, adding another new number, printing the array again, pushing down this time, and printing the array. Save both of these files. Change to source. Compile. Change to bin. And run. Now we're just alternately pushing up and down. We see this board right here is the initialized array. It pushes them up correctly. Then it adds a 1 below this 2, and then pushes them down correctly, and the 2 gets stopped like it should. It adds another number and pushes up. Then it adds a 1 down here and pushes down. And here we have a problem. It pushes the numbers down. It combines this one and this one into a 2, and then this 2 hits it, and they combine to a 4. In the actual 2048 game, this isn't what happens, so we need to find a way to prevent this error from occurring. Otherwise, it looks okay. To explain what happened a little bit better, we had let's say we had a 2 up here, a 1, and that's it. Let's just say we're looking at the B column right now. What happened when we pushed down is that this 1 moved down and combined with this 1 to make a 2. Then this 2 moved over and became a 4. That's not what needed to happen. What needed to happen was this 2 had to combine correctly, but then this 2 should have stopped. There can't be a double combining within one move like that. So this should have been the result. The way to do that is we have to keep track of what positions are already the result of a combination. So we're going to need to add yet another thing to our pushing methods. So we'll start with the push up, because that could happen when pushing up too. We will make a Boolean array of already combined and set that to 4 false values in a row. And then, in this else statement, this is the only time where things are combined. So, in this case, x will be a number between 0 and 4, which will correspond to the position of the newly combined number, which can correspond to one of these Boolean values. So we'll set already combined x is equal to true. And then in the same else thing, we'll need to check and see if the spot we're looking at was already the result of a combination. So we'll make an if statement. If already combined x is true, we don't need to say equals true, then we'll do the same thing that we did for the else if, as if it had found a number that was not equal to it. So we'll go to one position lower and put in the new value and empty the old place. And then we'll only do this other stuff if that test is not true. So if the place we're looking to move to has already been combined, we won't move there, we'll move to a spot one lower. Otherwise, we'll do what we were doing before and just mark that this spot has been combined. So I'll copy all of this and place it here, and we have to make everything backwards. Again, so change x plus 1 to x minus 1. This is for the pushDown method. Change x plus 1 to x minus 1, and everything else can stay the same. Now let's save and run a few tests on that. Okay, I'm going to change to the source directory. Do my compile thing again, and there's already errors. Already combined. It's having a problem finding that. So let's go back to our thing. It's probably, oh, I didn't add this array to pushDown. So that probably takes care of the issue. Okay, it seems that did it. Let's change to binary and run the program. Okay, now this will be harder because we have to see if there's any time where it would have done it the old way and see if it does it the new way correctly. So it pushes up correctly. It pushes down correctly. Pushes up correctly. Pushes down correctly. So far it doesn't look like there's any times where this would have happened. Okay, well the only thing to do in that case is run it again. Hopefully we'll see it. It looks promising in this. Okay, here we go. In this last column here, we have a 1, a 0, a 1, and a 2, and then it pushes up. It combines these two 1s to a 2, and then places the next 2 beneath it instead of combining them to a 4. And since we're doing the exact same thing for both up and down, I'm confident at this point that both methods are behaving correctly. So now all I have to do is make the left and right methods. So copying pushDown and placing it here and changing this to pushLeft. Pushing left. Now more things we'll have to change this time. In this case, we have to look at rows as a whole instead of columns. So the outer loop will be X and the inner loop will be Y. And since we're starting at the left this time, we will have Y start at 0, operate as long as Y is less than 4, and increment Y each time. And then, as long as the game board X and Y is not equal to 0, we will find the value. We'll change this to capital Y. And we'll have to move Y backwards again, going back towards the left, because we're scanning from left to right and then moving it back to the left. So Y will have to be Y minus 1. And then as long as Y is greater than or equal to 0, and the place we're looking at with lowercase x and a capital Y is equal to 0, we will decrement Y. Then if capital Y is equal to 0, we will place the value at the board at position X, row X, column 0, the first column. and empty the old spot. Otherwise, if the game board at row X, column capital Y is not equal to the value, then we have to change the game board at row X, column Y plus 1 to the value. So one space over to the right will take the new value. Or if already combined capital Y, this is referring to the we don't need to actually change the Boolean array because it's just a simple array of 4 Boolean values. Doesn't really matter that we're going left to right versus up to down. The game board at X Y plus 1 will take the new value if that's already been combined. Otherwise, the game board at X, capital Y will multiply by 2. We'll set the already combined Boolean at that position to true and empty the board, empty the old position. And then let's just opposite everything for pushRight, and then we'll test our left and right methods. So we'll change the name of this method to pushRight. I copied and pasted it. We'll change the text to pushRight. The Boolean is fine. The iterating through the rows is fine. But we have to go backwards now again through the columns. We'll have to start at the end at y equals 3. Operate as long as y is greater than -1. Decrement y each time. Change the value of capital Y to being y plus 1. Operating as long as y... Hold on, I think I might have gotten something wrong here. Let me look at this. No, we did that right. Operating as long as y is less than or equal to 3 and the game board is 0, we'll increment y, scanning for empty spaces. Well, why do I have y equals 0 there? I need to change this to -1 up here in pushLeft. I need to check that against my pushUp. Okay, that's correct. I had made a minor error in pushLeft where I was stopping too soon. So in pushRight, I need to check and see if we've gotten capital Y to the 4th position, or the 4th index, which will be after the end of the array. Then I can set the game board at row X, column 3, the last column, to the value. Nothing to change here. This capital Y plus 1 needs to change to capital Y minus 1. Y plus 1 changes to Y minus 1 again here. And all of this should be able to remain the same. So I'm going to save this and change what we do here. Right now we have all this going on with pushing up and pushing down. I'm going to copy all of this and then push left and push right. So we'll go through this 3 times again, but this time, each time around, we will add a new number and push up, down, left, and right, adding a new number before each operation. So, saving this file, and changing to the source directory, compiling, changing to the bin directory, running the file. So let's look through these a little bit more carefully. We start with this position of 1s, we push up, that goes correctly. Pushing down works correctly, and it has the 2 and the 2 here instead of the 4, which is correct. Then it adds another number and it pushes to the left, and something very wrong takes place here. pushing to the left has completely ignored these two 2s and replaced them with 0s and did everything. It just erased this whole first column. So we need to take a closer look at pushLeft, and I'll assume that there's a problem with pushRight as well. It doesn't appear to be. Well, there is. It ignores this one. So we did something differently with left and right than we did with up and down, and we need to do something differently to prevent this error from occurring. So let's take a closer look. Okay, I've spotted the error in the pushLeft function. We start operating at the leftmost column, and we don't need to because we need to leave that one there. So we have to start at y equals 1, which is the second column in that row. And it looks like we've done the same thing for pushRight. Instead of starting at 3 and going down, we need to start at 2 and go down. And this matches with what we're seeing in pushDown. We have x starting at 2 and going down. And in pushUp, we have x starting at 1 and going up. This should solve the problem. So change to source. Do our compile command again. Change to bin. And run the code again. Let's look more carefully now. Okay, so we have our initial board with 2 1s, 3 1s, and a 2. It pushes them up correctly, adds a new 2 at the top layer, pushes down, moves the whole thing down correctly, adds a 1 up top, pushes to the left correctly, combining these two 2s to this 4, moving this 2 to the position just to the right of it, and moving this 1 just after that. Adds a 1 and pushes to the right, combines the 2 1s in the top column correctly, and it looks, from what I can see, to be behaving correctly. I'm just checking through all of these real quick. This would be a really bad game to just go up, down, left, and right in that sequence. I'm satisfied that we have all of these methods working properly. If we do not, it'll come up later. So let's review what we have in our game class. We have an integer array called GameBoard and a randomizer as part of the class game. When we make a new instance of the class game, we initialize GameBoard as an 4x4 array of integers, and each position in that array is initialized to 0. We have a debugging method that prints out the array in a way that we can look at it. We have a method to add a new number. We use empty spaces x and empty spaces y, which are both array lists of the type integer, and we find all of the places that are 0 that we could add a new number. I wasn't looking specifically for this when we were testing, but I don't think it ever overwrote an existing non-zero number with a new number, so it looks like that's working correctly. If we had tried this enough that the whole thing got filled up, I think the program would have crashed. That might be worth trying sometime. Anyway, we randomly choose a position. 3, 2, 1. We randomly choose a position, and we randomly choose whether or not we're going to place a 1 or a 2, and with a 90% chance of 1 and a 10% chance of 2. And then we place a new number at a position on the board. And then we have 4 methods for pushing in a certain direction like you do in the game. PushUp is working properly, pushDown is working properly, as are pushLeft and pushRight. As best as I can see, everything is checking out. So that's all we're going to cover in this episode. In the next episode, we're going to begin talking about the graphic user interface.